When you get your answer, check it with a friend. Did you see it, Ben? Okay, so like I was telling Jaheen, there'll be an arrow on there that you could copy and paste. And do you know how to make the subscripts on whenever it's a Google Doc? Okay, if you look right here, you would highlight your subscript and then you go to format. And then you would have to choose text and come down here to subscript. So in this case, of course, it unsubscripted it because I had already done that. So format, text, and then subscript will make you a subscript. And then probably the easiest way to do the arrow is just to cut and paste the ones that I've already got on there. The test on Thursday is going to be, y'all are going to have to type everything in. It's not multiple choice. So if you think it would be, not on Thursday, I'm sorry, on Friday. If you think it would be better for you to do that by hand, you can come after school Thursday and take that on paper. You just need to communicate that with me. I can put y'all into the lab, spread you out. Anybody that's in tutorial still continues to wear their mask. All right, let me go ahead and pass this out while I get it. So you'll want your, when you get through, you want to check this with somebody? And I'm just passing you out an activity series. Please don't write on them. So all you'll need out is your peak sheet for today.
So we're only testing today.
Combustion and single replacement. Yes, ma'am. Mm-hmm. And I have those dates up there. So this week you have quiz today, and quiz tomorrow. Tomorrow, there's just going to be a bunch of reactions and you just have to say what type they are. You don't have to balance them. You don't have to finish them. Nothing except saying what type they are. So hopefully that'll be an easy one because you'll also see some things like that on the test. So we're doing the test, but not until Friday. We're going to spend 2 days, y'all, working on review, and I'll tell you more about that tomorrow. And then we'll go over it. And the test won't actually be until Friday, so that gives you plenty of time if you need some help. The test will be open note, so there will be no retest. The only re-quiz that runs out this week is the one that we took on Friday. So the 2 that we're taking this week, they go until next week. So you run out of time as far as re-quizzing. And my tutorials are in Google Classroom, and then they're also up on the board too. I think that's everything on that. All righty. So, okay, so Jaheen and Ben, if y'all will go into your, let's see if it's dropped yet. Let's see. Why do I have it in here twice? I wonder which questions it is. All right, if you'll go into your Google Classroom, y'all, I'm going to give y'all yours in a minute. And there's how many problems? 5 problems, I believe. Yeah, 5. So don't miss the one that goes on into the next page, okay? All right. 3, 4, 5. Whew, pardon me. Everybody get one? Everybody got activity series? All right, and you'll have 10 minutes on this. All right, hold on 1 second, Ben. All right, Ben, if you'll let me know when you have, if it comes to you, please. All right, Ben, if you'll go ahead and turn yours in, please, sir. All righty. All right, our last ones that we have as far as types of reactions are the double replacement reactions. And we won't have a separate quiz over these. You'll just see them on the test. You do have your practice for those, and then in the review, there'll be some practice too. So we're no longer using the activity series. That's only used for single replacement reactions. And instead, we're using the solubility rules down here. because we do have some NRs on these also. So a solubility rules tells you whether something will dissolve in water or if it will not. So let's kind of start and we'll go over those to begin with. If something is soluble, that means it will dissolve in water, and we'll describe that as AQ. If something is insoluble, then that means it will not. So it will stay as a solid. On the key, there's also some PPT, which stands for precipitate. Those mean the same thing. So down here, insoluble means it's a solid. My exception means it's AQ. So all of these things are soluble. They will dissolve in water. And then these are our exceptions. So anything that has a group 1 metal or ammonium attached to it will always be AQ. There is no exception. All nitrates and all acetates will always dissolve in water. They're AQ, and you can see there are no exceptions. So when you have an ionic compound, a metal plus a non-metal, you're either going to be looking for the metal part of it in these set of solubility rules, or you're going to be looking for the non-metal part of it in these solubility rules. Chlorides, so anything that's combined to Cl, Br, or I, all of those are aqueous, but these do have some exceptions. So an exception changes it from what it usually is to the opposite. So that means if I have a chloride that is bound to silver, lead 2, or mercury, instead of being soluble like they are, these are all now insoluble, or they will be solids whenever you mix them together. So you decide where you want to mark yours, because you will have open notes test on this. So this can be your solubility rules, and you do what works for you. Make sure you don't think that S means sulfur. All sulfates are AQ. They will dissolve, except if I have a sulfate that's bound to silver, lead 2, mercury 1, barium, strontium, or calcium. So those are my exceptions. And notice some of them are pretty specific. It gives me this specific lead 2+, not another lead ion. Mercury 1, not mercury 2. So some of them are very specific. And then we have our list of insoluble things, or things that will be precipitate or solid when they're mixed. Carbonates, sulfites, and phosphates, those compounds always form a solid unless they're combined with group 1 metals and ammonium. There's nothing that's going to combine with a group 1 metal or ammonium or acetate that's going to make it become a solid. All of those things always are going to go into solution. Hydroxides are solids unless they're combined, once again, with a group 1 metal, ammonium, calcium, or barium. Sulfides are solids unless it's a sulfide that's combined with a group 1 or group 2 metal and ammonium. And then any oxide is going to be a solid unless it's combined with the group 1 metal, ammonium, calcium 2+, or barium 2+. So you start over here when you're working these, and we use our products. We're not looking at our reactants. And you try to find them here, or try to find them here. And once you found them, then make sure you don't have an exception that will kick it over from what it usually is to the opposite. So like I said, these are the hardest ones that we do. So to know whether we have a good reaction, it's not as easy as with our single replacement reactions. So rules for predicting double replacement reaction. Predict the products of the double replacement reaction and indicate the solubility of both. So when you do these reactions, your products, you don't have to worry about your reactants, but your products are going to have, whether they're AQ, whether they're solid, or we're going to have some that are water, so those would be liquid. So you have to indicate both of those on the product side by either placing the symbol AQ if it will dissolve in water, or S if it will not. And this is what you're going to be using your solubility rules for. And like I said, as you work for your practice, mark on your solubility rules if you have something that's going to help you use them on the test on Friday. If the compound is soluble, that means that it will remain as ions in the solution. If it is insoluble, then the compound precipitated out of the reaction or became a solid. You have to have, so there's several ways that you will know it's a good reaction. If you have at least one insoluble, then that reaction will occur. So you have to have at least one thing that is a solid. That's going to tell you there's a good reaction. If only soluble products are, the reaction will not occur because no precipitate is formed. So if you have two AQs, then that's when you're going to have an NR reaction. If a gas is formed, then the reaction occurs and you would have a good reaction. So our examples of our gas that you're going to be looking for is H2S and HCN. Those are both acids. Hydrosulfuric acid and hydrocyanic acid, or sometimes that's just called cyanic acid. But both of those exist as gas. And as a gas produces, then that is a good reaction. If water is produced, the reaction will occur. And this happens with a specific type called acid-base reaction or neutralization reactions. And we'll look at a couple of those as we move along. If the reaction occurs and one of the compounds formed, so one of the products is soluble, then that compound, we're not going to worry about that. We're going to take out number 5. We're just not going to have time to do it. Great. If y'all want to do that, y'all can come on with me to AP Chemistry. So a reaction occurs if a precipitate is formed, if a gas is formed, or molecular covalent compound is formed, usually water. But remember, a covalent compound is equal to 2 nonmetals. So you could have something like CO2 formed or SO2 formed. That would still be a good reaction. So the time that you're going to have an NR is if your products are AQ and AQ. That's going to be an NR. Ionic compounds are salts and they're solid, so they have to be put in water and dissolved to see if they will even react with each other. If I just put a solid with a solid without any kind of solvent, nothing's going to happen. So if they dissolve and the ions can interact, then we're going to get a good reaction. If not, those ions are just going to stay floating in that solution. All right, so let's come back up here and look at some of these examples. The other thing that makes these a little bit hard is that you're writing a whole bunch of ionic compounds. And so you're really having to check your charges and make sure your compounds are written correctly. So double replacement reaction occurs when the cations, which are your positive ions, usually metals, we have a few polyatomic positive ions, switch places. You don't need the activity series. Instead, you're going to have to use your solubility rules to predict if the reaction occurs. Once they have switched places, look at your solubility rules to see if it's going to be a good reaction or if you're going to have an NR. And then if it is a good reaction, make sure your new compounds are written correctly. So we'll just look at a couple here. So sodium chloride plus magnesium oxide. So my sodium and my magnesium are going to switch places. Those are my two cations. And then I end up with sodium oxide plus magnesium chloride. So that's going to be my first step. Sodium's a +1, oxide's a -2. That's why there was a subscript of 2. And for this compound, magnesium's a +2, chloride is a -1. That's why I had a 2 here. So once I've decided that, before I go to any balancing, I need to find out what state both of these are in. So if I look at, let's see, we'll come back down to our solubility rules. I'll rewrite them down here so people know which ones we're looking at. So we're interested in finding sodium oxide and magnesium chloride. Okay. So anytime you have a group 1 metal, those are going to be one of your easy ones because group 1 metals fall right here. They're soluble and there are no exceptions. So remember, if we said it's soluble, then we say it's AQ. So this would be AQ. That would go into solution. The next one, I'm either got to find something about magnesium or something about Cl. And if I look through here, there's nothing specifically about magnesium, but there is a rule for chlorides. And it says chlorides are aqueous unless they're bound to silver, lead, or mercury. And it's not bound to any of those. So this is also AQ. So once I find out I have AQs, and I'm going to quit working on that problem because that means it is an NR. If I mix all that together in water, they're just going to stay as ions floating around. They're not going to have any kind of reaction. So I'm going to leave that one like it is. All right, let's look at the next one. We have KMnO4 and sodium. I think that's chromate. So my potassium and my sodium are going to exchange places. And I get NaMnO4 plus C2O4. So I let my sodium and potassium exchange places, and then I made sure that my compounds were written correctly. So now I have to look at its solubility rules. Does anything jump out to y'all about those? Sodium, MnO4, and potassium? They're both what? Group 1. Are group 1 metals going to ever be anything besides AQ? That's my very first rule. My very first rule says group 1 metals are AQ and there's no exceptions. So these are both AQ again. And if it's 2 AQ, then I'm going to quit working on it and I'm just going to say, never mind, that wouldn't even occur. They're just going to not mix and they're not going to react. So that's what you have to do with those. You have to go and find that. So let's look at more, let's look at a couple more on your practice. So on your practice, on the first page is just solubility worksheet. So if you're having trouble figuring out how the solubility rules work, then this just gives you some practice on that. This is not about reactions on that first page. You're just going to say whether something is AQ or something is S. That gives you a little bit of practice on that. All right, let's see. Let's go to the one that says worksheet number 5. So that's going to be the last page in y'all's practice. So let's look at a couple of those. So we're going to move over to the practice to do some more examples. All right, let's look at a couple of these. All right. So we'll just start here. Then we'll just start with number 1. We'll go through about 3 or 4 of these. So my first one, aluminum iodide plus mercury 2 fluoride. So that tells me that it said plus 2. This is the -1, so it'd be HgCl2. So my metal and my aluminum are going to change places. I'm going to end up with aluminum chloride plus mercury iodide. All right, so before I do any work on that, I'm gonna look at my products. So look at your products, look at aluminum chloride and mercury iodide and see if you can figure out whether they're AQ or whether it's an S. You think it's an S, okay, for the first one? Okay, and what about the second one? Okay. Okay. So we got some that think a couple of S's. Anybody else have different thoughts on it? Everybody got an S for both of them? Yes, no? What'd you get, Aaron? Okay. So on here, if I look for my aluminum chloride, which part do I find my rule about? Aluminum or about the chloride? About the chloride, right? And it says that rule is under your top set where it says soluble compounds. That rule is the third down. It said chlorides are AQ. And then you come over and you see the exception. So what would make a chloride be a solid instead of an AQ if it was bound to what? Silver or mercury. And does it have any of those exceptions? That's not any of those exceptions, right? So this would be AQ. And that's why I did that first, because using the solubility rules are a little hard. And that's why I did this first page that was just about that. That just helps you use the solubility rules. Now, the second one, I have my iodides, okay? And my iodides are on that same list with the chlorides. And it says iodides are AQ unless it's combined with what? Silver, lead, or Hg, mercury +1. Is this mercury +1? Is it, if it was mercury, if this was mercury +1 and I is a -1, would I need that too? So this is tricky one because this is a mercury +2. So it doesn't fall into that exception. So this is actually another AQ. And really over here would even be easier to see right here. This is mercury 2, as I've said before, except it's mercury 2 as a reactant, it's mercury 2 as a product. And the only mercury that's listed on there. So this is an NR. Although it was a tricky NR. All right, let's look at another one. And you always obviously want to check that before you do any balancing, although I don't think these are too hard to balance. But if it's an NR, I'm not going to go to a lot of trouble. AgNO3 for silver nitrate plus potassium phosphate gives me potassium nitrate plus, what else do I have? Silver phosphate. All right, so we'll start with our KNO3. What group is K from? Group 1 metal. So those should be ones that are easy to you. Group 1 metal. Now remember, I'm not talking about hydrogen. Group 1 metals have to be aqueous. They always will dissolve in water. So this is going to be AQ. And once again, it is the very first rule listed. Group 1 metals, AQ, and there are no exceptions. So my next one now, I got to come, and there's not going to be a rule about silver. Silver belongs in a lot of exceptions, but I've got to find the rule about my phosphates. So that comes down, and that's in those set of rules under insoluble compounds. So it says phosphates are insoluble or phosphates are solids unless they're bound to a group 1 metal, which silver is not a group 1 metal, or ammonium. So this is not an exception. So this is going to stay as a solid. So finally, I got a reaction that's not an NR. So that is a good reaction. So you would need to move on and balance this one. I noticed that I have 3 silvers. I'm going to put 3 here. And what else do we need? I feel like we need something else. 3, oh, there we go. 3 right there. I think that balances it. All right, so y'all practice some of those at home. I'm going to show y'all an example of one that produces water. We'll start with that tomorrow. And then I'll go ahead and give y'all your review. Or we may spend another day on these. Won't matter. Just saying what kind of reaction it is. It'll be completed reactions. You don't have to balance. You don't have to write the products. You just have to look at it and say whether it's combustion, single replacement, double replacement, synthesis, or decomposition. No notes. No notes. All right. If somebody, y'all grab your wipes, please. All right, Ben and Jaheen, tomorrow quiz just over saying what type of reaction. You won't have to balance them. You won't have to finish them. You won't have to write them. You'll just classify.